Hey everyone, welcome to 5.8 inverse trig functions and their derivatives. So in your book you have all of these things down below me. I'm just kind of use those as a reference so that way I don't have to keep looking down and up at the book. So you have all your arc sine, arc cosine, arc tangent. Remember the -1 is the same as saying the arc. So the top one is for just if it's u. We got u primes, and then if we have the same thing for du dx, we have all sorts of stuff as far as how does that go. So we've got derivatives and all of that very, very good stuff here. Okay, so what we're going to do is let's just go through and just do a couple of these just to make sure that we got it. So we have the derivative of arc sine 2x. So that means it's this first one that is right below here, that sine inverse of u. So it's going to be u prime square root of 1 minus u squared. So what I'm going to do is I'm just going to do that square root stuff first. I don't know why, that seems to be easier for me. So we can say that's going to equal the square root of 1 minus 4x squared, right? Because it's the 2 is squared and the x is squared. And then we're also going to have the derivative of that, which would be 2 on top. So it would be 2 over the square root of 1 minus 4x squared. Okay, good. So now the next one we have arc secant e to the 2x. So let's do arc secant is that one that says the absolute value. So let's do that part first. Absolute value of u, which is all the stuff in here, e to the 2x, times the square root of u squared. So it's going to be e to the 4x, right? Because if you think about it, e to the 2x squared, right? When you take a power of a power, really all you're doing is multiplying this 2 times this stuff. So that would give you 4x, and that's going to be minus 1. Okay, and then we have to multiply that by the derivative of e to the x. I'm sorry, e to the 2x. So that's going to be e to the 2x, and then we have to take the derivative of that, which is just going to be 2. So we should end up with 2e to the 2x all over the, where am I here? E to the 2x, and we have that squared. Okay, good. And then this absolute value, because e is always going to be a positive, we don't need this absolute value. So this absolute value goes away, and this e to the 2x and this e to the 2x goes away. So you end up with 2 over the square root of e to the 4x minus 1. All right, so if you can see that, my marker's kind of dying here. I'm going to need a new one pretty soon. But you can see that should be your answer, and there is some good work for it. Okay, so there you go. There is a couple of examples. Now let's do one that is a little more tricky, because if we don't have a picture with this, then this gets a little bit more difficult. So let's actually go through and read this first. So here's our example. A photographer is taking a picture of a 4-foot painting hung in the art gallery. The camera lens is 1 foot below the lower edge of the painting. How far should the camera be from the painting to maximize the angle subtended by the camera lens? So that word subtended, you might say, Mr. Bartman, I'm not sure exactly what that means. Well, let's look it up. All right, a quick Google search gets you to here. So a definition of a subtended angle, an angle made by a line, arc, or object. So here, the subtended angle of the tree from the person's point of view is 22 degrees. So we're going from here to here. So what we're trying to find is that view from the camera lens. All right, that's going to be the subtended angle. Okay, so now we know what that means, and this is kind of a good thing to try and do. Let's actually, when I say that, I mean, if you don't know what subtended means, look it up. I mean, you are watching this video, which means you're on a computer, which means you could probably access the internet, because that's how you are watching this video. So if you don't know something, pause, look it up, come back. Oh, okay, I know what he's talking about. All right, so let's actually take a picture. Let's draw a picture of this picture. Okay, so first we have our picture right here, and it is obviously a very good picture, worth a lot of money. There it is. And then we have our camera. That looks exactly like a camera, correct? And I know that the camera right here is 1 foot. I know that my painting is 4 feet. So what I want to know is, I want to know the angle that goes from here to there. All right? So we have a whole bunch of angles. We could say, let's say this whole thing is theta. And let's say this one is, call that one alpha. Let's call it beta. That seems like more fun. Let's call that one beta, and let's call the other one the one that's down here. Let's call this one alpha. Okay, so now we have three different angles, and we want to be able to maximize beta. When we maximize beta, think about maximizing something. If we take the derivative, set it equal to 0, that's going to be either our max or our min, right? So, this marker's just kind of going all crazy. So if we can figure out the derivative of a function, set it equal to 0, we should be able to figure out our maximum. Okay, so what we want to do is let's figure out beta, theta, alpha. Okay, so what we're going to do, let's just use this. This beta angle is going to equal theta minus alpha, right? It's going to equal the big one minus everything. Okay, and we want to know also how far is it from here to the painting, right? I don't know how far that is. That's going to be x. Let's just put an x there. Okay, so now if we're using theta, I'm going to say, we don't know what beta is. We're trying to figure that out. So we're going to say beta is going to equal, well, theta I can write out. If I can figure out that angle, I know the opposite and I know the adjacent, so I can use tangent. So for theta, opposite over adjacent, right, will work out. So let's use opposite over adjacent. So we're going to use opposite over adjacent. I know for theta, opposite is 5 and adjacent equals x. I don't like having that x in the denominator, so instead of using tangent, can I just flip them around and use cotangent? Which I'm going to do. So I'm going to say cotangent. So let's just say cotangent theta equals x over 5. So that means the inverse of cotangent is of x over 5 is going to equal my theta, right? Because if I do the inverse cotangent, this will go away, and I'll have just theta left. Okay, so we've got that for cotangent. And then let's do the same thing for alpha. Alpha is this small angle right here between the horizontal and the bottom of the painting. So that means the opposite is 1, the adjacent is x. So I'm going to use cotangent again, inverse of x over 1. Okay? I mean, that kind of makes sense. It's the same process, just I'm using 1 and x instead of 5 and x. All right, good. So now what we're going to try and do, remember we wanted to figure out the derivative of this, set it equal to 0, and then we can find our max. So let's find that derivative. So what's the derivative of inverse cotangent? So I'm actually going to write this again because I think I'm running out of room here. Inverse cotangent of x. Okay, so now let's go through and actually take those derivatives. So that means I'm going to say d beta over dx is going to equal inverse cotangent. If you remember what inverse cotangent is, let's go back to our thing over here. Inverse cotangent is going to be negative u prime over 1 plus u squared. And so if I go through and I do that, I should end up with negative 1/5 over 1 plus x squared over 25. Minus, well, let's do this one. It's going to be 1 over 1 plus x squared. Right? Oh, you can't really see all that. I'm sorry. That's better. Okay. So now we have that. Can we get common denominators, things like that? Well, of course we can. We can rewrite this as multiply this everything here by 5, and we get d beta over dx equals, let me just write this down here, negative 5 over 25x, 25 plus x squared, minus, or let's just say minus, ooh, that should be a negative right there, negative, or let's make it positive, 1 over 1 plus x squared. Okay, and then by simplifying all sorts of stuff, I'm going to skip some steps so that way it doesn't take you super long. Dx equals, I've got 4 parentheses 5 minus x squared over 25 plus x squared times 1 plus x squared. So all I really did was get common denominators, and then we can combine some stuff. So if you want to see how all that works, come and find me. We can figure it out. I'm not going to go through all those steps. Okay, so now I want to say this is equal to 0. Well, that's equal to 0 when just the numerator equals 0. So all I'm going to do is say that. So it's going to be 4 parentheses 5 minus x squared. I don't care about the 4, so 5 minus x squared. When is that equal to 0? That's equal to 0 when x equals the square root of 5. So when x equals the square root of 5, that's going to maximize our subtended angle. And the square root of 5 is going to be about 2.236 feet, because we're dealing in feet. So it should be 2.236 feet. All right, so that would be how you do this problem. We're using cotangents, and then using a little simplifying, knowing the formula for getting derivatives equal to 0 to maximize some stuff, and then getting our answer of 2.236 just by plugging in the calculator. All right, so there you go. There is this section. Good luck.